Alright, so let's go back and revisit this idea of completing the square. I really do expect that this is something that you would have covered last year, talking about graphing quadratic formulas in vertex form. I'm hoping this equation looks familiar to you from last year. So what we're going to do is, and just a reminder with vertex form, that's when you wanted to graph a parabola and you were told some point on the parabola was this HK value. So what we're going to do is we're going to talk about how to complete the square. And I found this visual. Some of you maybe have seen it before. And if you were at Ames for your freshman year, you really should be familiar with this idea of using actual geometry to explain the algebra. When I have x, that means I've got a square with x on one side, x on the other. If I have some constant times x, I can represent that with its own rectangle. And what we're going to do is, to complete the square, we're going to take this rectangle and we're going to cut it in half. And we're going to place 1/2 along each side. So now this side is x plus b over 2. This side is now x plus b over 2. And you'll notice we have this little region here that is not filled in. We want to be able to quite literally complete the square. So we put this little box into this corner, but once we do that, it's no longer the same value, the same area that we had to begin with, which is why we turn around and we subtract this little area again. And so this little piece right here is where your k value will come from. So let's take an example. I've got one down here. Should be a pretty straightforward example. Your middle term is your b term. You're going to take that term and you're going to divide it in 2. Now this term, we know that our goal is going to be something that looks like x plus this b over 2 term, in other words the 1, plus some other stuff to be able to get this perfect square. Sorry, I'm just having some problems with my pen right now. So completing the square is, we're part of the way done, but we need to understand what this little term out here is. So what I typically will do when I'm completing the square is I like to take my first 2 terms, I like to put them in their own set of parentheses. I like to indicate that some third term will go here. And I'll take my third term and put it outside, and then show that I'm going to subtract whatever this term is out here. Now, I want you to go ahead and actually factor this, FOIL this, to confirm for me that the term you're going to get here is just going to be a 1 for this problem. Factor this, FOIL this, prove to yourself that this will be a 1. If I add 1 here, means that I need to turn around and subtract that same value on the outside. This is going to be our perfect square. By the way, if you want to look up more about this, this would be called a perfect square trinomial. On the outside, we're going to take this 5 minus 1. And we're going to simplify it. If I wanted to use this for graphing, I know that the vertex would be at the point -1, 4 from this vertex form that I believe that you learned last year. So that's going to be the most recent place that you've learned completing the square, if I'm correct. And we today saw that we can use it in a couple of other places. For example, there are going to be some equations that using completing the square will help you to find the integral because you can get it in the form that uses the arctangent. So I'm not going to practice with any calculus just yet. I'm just going to do a couple more videos on completing the square examples, and then we'll get back into the calculus.